Hi everyone. So shall we start?
Yes, we can start.
Yes, ma'am.
Today I'm going to discuss about data structure and algorithms. So data structure and algorithm, what is it, and what kind of data structures are there in the programming languages. So these are the basic building block of a computer program or a software. So we will talk a little bit about them. So um, do you have any idea about maybe you have heard something about data structures and algorithms, this term? Maybe you are familiar about these terms.
I don't know, ma'am, we are familiar or not. Maybe later on we can understand. Yes,
Okay.
forgot that.
One minute. There's something there. Okay.
Click on
Okay. What is the data structure? So data structure is a storage that is used to store and organize the data. So uh, when we want to when we want computer to do something or some program, so where like we just generally want to provide some data to computer, and we want that computer should store that data, or it should process that data, we can retrieve the data. So we want some processing on data generally in the programs. So we need some methods, like computer needs some method or some way so that it can hold the data efficiently, it can update the data efficiently, we can retrieve the data from the computer efficiently. So there should be specific ways or methods to store the data, because we have multiple kind of data, and we have a different combination of data. So accordingly, we need different data structures. So the data structure is a way of arranging data on a computer so that it can be accessed and updated efficiently. So data to be accessed and updated efficiently, we need some data structures which can be used for processing, retrieving, and storing the data. So these are the methods to do the data handling in a proper manner, and these are the basic building block of a database of a program, uh, because without that we cannot write any program. So, and if we talk about the algorithms, so what are the algorithms? Algorithms are the finite sequence of instruction, each of which has a clear meaning and can be performed with a finite amount of effort in a finite length of time. What does it mean? Like if we want a computer to do some work for us, so first we have to provide a set of instruction to a computer which should have a clear meaning and which can be performed in a finite amount length of time, and which is each step should require a finite amount of effort. So that is called algorithm. And do you know algorithm word come from Al-Khwarizmi? The photo is shown here. So he was a Persian mathematician. So from the name of him, the algorithm word uh, came here. So algorithm algorithms are like some steps which we give to computer. So these should be precise enough so that, and also it should be understood by human being. So algorithms can be understood by human being, and but when we want a computer to perform that instructions and the program, so we need some formal languages, like we have C++, Java, .NET. These kind of languages, we need to convert that algorithm into a executable program. So algorithm is the basic steps we write, and when we have to give these instruction to computer, we convert it into a formal program code. So we use the formal languages for that. So for example, in the daily life, if we talk about the algorithm, so if we want someone to make lemonade, how will we instruct him or her? Like, what will be the steps to prepare lemonade? So step one will be like, take 200 ml of water. Step two is like, put 10 gram of sugar and stir until the sugar is dissolved. Step three is put 5 ml lemon juice and stir until a homogeneous mixture is obtained. Step four is add black salt according to taste and stir until the salt is dissolved. Step five, add ice cube if needed, and now lemonade is ready. So in this algorithm, each steps has each steps required some effort, and all the steps have clear meaning that you have to do this thing, and this after that this thing. And then each step can be performed with a finite amount of effort in a finite length of time. Every step requires some time and effort. So this is very clear. So this is an algorithm which we can understand and we can make someone understand. So this is the algorithm, but if we want to give it in a computer program, we will need a specific formal language. So that will be the final computer program. So that is about the algorithms. Now we will talk about the data structures. So classification of data structure. So the broadly we can classify the data structure in two parts, that is primitive and non-primitive. So in the example of primitive is like a integer, boolean, character. So maybe you are aware of these terms, integer, character and all. And for non-primitive, it can be further categorized in linear and non-linear. And linear can be further divided in static and dynamic data structures. An example of static is array. Maybe array is very familiar to everyone, maybe. And dynamic data structure are stack, queue, linked list. These are the dynamic data structures. And for non-linear, we can take example of like graph and tree. So we will discuss about them in the later slides. So these are the only classification of the data structures, like on the basis of some things. So we will discuss in the next slides. Sorry, just give me one moment. Yeah, sorry. So first we will talk about the primitive data structure. So primitive data structure can store the value of one data type. For example, if we want a computer to hold one value or one data type, if you want to see your result in some computer program, so you will provide, a computer will ask you to enter the roll number. So you have to give one integer data type, which will be a roll number. Suppose your roll number is only integer. So when computer will ask you to provide the roll number, what it will do, it will declare a variable which can hold only one integer data type. And also this integer data type will like when computer will declare this variable, it will assign a specific memory location to that data type, and then it will ask you to enter the roll number. And when you will enter the roll number, that value of the roll number will go to that specific memory location which was given to that variable. So it can hold a single value in a specific memory location. And for example, it is integer, character, boolean. These are the example of these primitive data structures. So if we talk about integer are the data types which contains the numeric values only. And it can contain the whole number that can be either positive or negative. And if the range like the number is beyond the range of the integer, we can use the long data structure. And if we need to provide the decimals, so we will require a float data structure. So this is for the numbers, we can use these kind of data structure. And for the characters, we can use the data type as a char or a string, like character is a data type for character type of data, which can be in lowercase or in uppercase. Similarly, there is one more data structure. There are multiple data structure for primitive. These are only the examples. So for if we talk about the Boolean data structure, so Boolean are like, it contains only true and false values. So if we need to check some conditions in our program, if something is true, then do this, or something is false, then do this. So we can use that Boolean kind of data structures. So these are some example of primitive data structures. So now we will talk about the non-primitive data structures. So because in the real world, when we work with computers, we cannot do only the holding and storing for a single data type and single data values. We need multiple data, multiple values to store and process in the computer. So here comes the non-primitive data structures in the picture, because non-primitive data structures are the data structures which can hold multiple value at the same time. So because the primitive data structure were able to hold only a single value, they can hold multiple values, and they can hold the store the values either in contiguous memory location or a random memory location. So both can be the case, like the memory location can be contiguous or random. So on the basis of memory location, we can further categorize these non-primitive data structures in linear data structure and non-linear data structure. So if the memory allocation is contiguous, then it will be a linear data structure. And if it is a random, then it will be non-linear data structure. So we will talk about these linear and non-linear data structures in further slides. So is there any doubt or something from you? Anyone?
No, not
Yes,
from
ma'am.
my
I
side.
have one though.
Yeah. Okay, you don't have any doubt. Anything is there? Now we will talk about the linear data structure. So linear data structure is in which we can take example first so that we can be able clearly. So the array, stack, queue, these are the linear data structure we can say. So as we know that array can hold the multiple values, so we can say that the linear data structure are the non-primitive data structure in which the data elements are arranged sequentially or linearly, and each element is attached to its previous and next element. So what does that mean? In this type of data structure, all our data elements are arranged sequentially in the memory. So all each element will be attached to its next and previous element. So it will create a sequential or linear format. So array, stack, queue, these are the example of linear data structure. So basis of memory size allocation in the initially, so we can divide them in static and dynamic data structures. So static data structure are what the data structure in which the memory allocation are fixed. Examples are array. So if we will declare some array, or so we initially we will provide a size. So like if we provide the size 15 to the to one array kind of variable, so like we have declared a array of integer which is having 15 size. We have to declare it in the initial of our program. So that 15 size will be fixed throughout the program. So you cannot, like, computer will not release the memory and it will not increase the memory. So if you need to insert more than 15 element, if you want to insert 17 element, it will not allow after 15, because the memory is allocated only for 15 characters, 15 integers. And in the same way, if you want to delete something, so you will delete five integers in the array, and it will be only 10 integers in the array, but then also the memory will not be free up for some other uses. So throughout the program, the 15 integer memory will be allocated to that variable. So it is a fixed memory size variable. So we call it static. Now next one is dynamic. So in dynamic, the memory allocation is not fixed. It can be done at runtime as per the requirement. So if we need to insert some data, we will not define any size initially. So whenever we are inserting data, computer will accept it and it will give a memory location to it. Same way, if we will delete the data, it will release that memory so that any other program or variable can use that memory. So example of these dynamic data structure are queue, linked list, stack. These are the examples. So obviously we can say that static data structure are not good for memory optimization, but dynamic are very, very good for memory allocation purpose. But in this we can see the another side. Static is very easy to traverse because each are contiguous and the memory is fixed. But from the dynamic, computer will provide any random location of the memory. So but they will be adjacent because they will have the memory location stored in the cell. So it will not easy to traverse the dynamic data structure. That it is easy to traverse that static data structure. That's why we use arrays very frequently. So that is all about static and dynamic data structures. Now if we will talk about non-linear data structure. Till now we have talked about all the linear data structure in which static and dynamic were there. So non-linear data structure are the data structure in which elements are not arranged sequentially, or we can say these are not linearly. So it is called non-linear data structure. So most common example of is tree and graphs we use in our programs. So this is a small introduction of non-linear data structure. Now we will take a look of a few data structure. So arrays. So maybe arrays are very commonly used, or you would also be heard about arrays. So we can say that array is a static linear data structures in which we can store the ordered collection of item, and as it is a linear data structure, so items are stored in a sequence in computer memory, and it has a fixed size, and also it can hold only the same data type. It means if we have the integer array, then it will hold only integer data type. If we have character data array, it will hold only character data types. We cannot mix the character and integer in the same array. So if we take example of array, so we have declared an array of integer is ARR, and I have given 14 values, 5, 4, 55, this kind of value to this array, and these are the 14 variables.
Richa,
Yes.
can I make a comment here?
Yes.
Actually, when you talk of Python, so Python has perhaps something called as dictionary. So I'm not sure whether dictionary is a data structure or an array, but in dictionary you can save character, you can save in the same dictionary, you can save character, you can save integer, you can save float, boolean, etc. in the same dictionary.
Yeah, so it is not array. We cannot call it array. In Python, you must have all arrays differently. Like we can, I don't know what they call the arrays in Python, but if it is storing multiple kind of data structure. It is not array. There are many data structure which can hold different kind of data.
Okay. So
So-
it's just a it's just a kind of data structure that is dictionary. So they call it as dictionary.
Mhm. They call it dictionary. In some other language, they call it record. In some language, C language, we call it class. So this is different data
Okay,
structure.
okay.
It is not array.
Okay. 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 Sure. Thank you.
Yeah, sure. Yeah. So for the array of integer, ARR, I have declared these 14 variable, 14 integers. So we will call this, we will say that size of array is 14. And as I have given the 14 integers initially. So throughout the variable, the computer will allocate the 14 integer memory space to this ARR variable. And if I will delete some elements, then also this memory will be allocated to this ARR variable. And also I cannot insert more than 14 character integers in this ARR variable. If I need to insert, if I need to, I can only replace, if I want to, like, I can delete 100 some element, then the memory will be free for one integer, then I can insert the one more integer. So it will work only in that manner. And if we want to access these elements of the array, we have to use some index. So generally we use I as index. We can take any alphabet. So we use ARR of I. That is the way to access the some individual items on arrays. So in generally most of the languages, that index starts from 0. So if we will go from first element, that will be ARR of 0. So ARR of 0 is 5, ARR of 1 is 4, then ARR of 2 is 55. So in the same manner, we will go till ARR 13. So this will 8 will be ARR of 13. So in this manner, we traverse the array. And as we have talked earlier, we can traverse the arrays in sequentially. We cannot go directly to some element like in between. If we have to go to 7 or 10, we have to go sequentially. So what will we do? We will take loop or iteration, and we will increase or decrease the index. Then we can traverse the array. So the syntax of looping is like it depends on the language, but general syntax we can say for I equal to 1 to n. So I will be the index, and can you give, n can be any value. Like if you will give the value of 6, so for I equal to 1 to 6, you do something. So it will go to ARR of 1, ARR 2, like it should be 0, sorry. I equal to 0 to 5, then it will go start from 5, 4, 5, 55, 78, 9, and then it will go to ARR of 5, that is 6. So in this manner, we can traverse the array, and then we can use, we can do any operation on the elements of the array. So that was a small introduction of arrays. So we can do many things with the arrays. So it is a data structure which is linear as well as static. So now we will talk about a stack. So a stack is also a linear data structure, but it is dynamic. It can have dynamic memory allocation. That means we don't need to provide the the memory size initially, as well as we insert the data. It will take the data and it will assign the memory, as well as we delete the data. It will free up that memory. So if we can imagine, like we can think that stacks as like a stack of books, stack of chair. So what we do to insert in that stack, if you have to insert a new chair on the stack of the chair, you have to insert the chair on the top of it. You cannot insert in between. Similarly, if you have to remove any chair of on the stack, first you have to remove the top chair, then you will remove the next chair, then you will remove the next chair. then you will go to that chair. So you cannot do anything in between. The top will be removed first, and the top will become first. So we can say that stack has only one end to insert and delete the data. So we can imagine, like in the stack of the chair, only they have only the one end where we can insert and delete the data. We don't have two ends. So it works on LIFO concept. What is LIFO? Last in, first out. So the chair which will be which is coming in the last will out the first. So it works in the last in, first out concept. Means the element which was inserted in last will be deleted first. Then only you can go to other element. So generally, we use push and pop operation to insert and delete the elements in the stack. So push is what push is for inserting the data in a stack, and pop is for deleting the data in a stack. So these are the operations which are used to insert and delete the elements in the stack. In the stack, generally we use the values, and also the memory address of the next adjacent element will be stored in the another cell of a data storage, so that it can access the next data. Now, if we will talk about application of a stack, so in our daily life, so if we have to perform some undo and redo operation, the stack are used in that. So undo and redo means if you write something in text editor and you do Control-Z or you press undo, then what happens? The work which you have done last, or the thing which you have written in the last, will be removed first, and the work which have done in the first will be removed in the last. So how it happens? If you have written A, B, C in your text editor, so in the stack, first it has A has been inserted, then second the B has inserted, and the top C has inserted. Now if you will do Control-Z, so what happens? You have written C in the end, so the C will go away. So it happens in that way. There AB is there and C has been removed. Then you do next Control-Z, or you do next undo. So what happened? B removed from the stack. Now only A is there. So that in that manner, that stack is used in that undo operation. In the same way, redo operation works. So here there will be a different stack for redo operation. I have not shown that. So these are stored in that redo stack, and then we will do that redo. Then again, the last element which have been undone will be come back as redo, and in the same way the next element will come. So the next stack redo will store the C and B, and when we will do redo, it will come again. So in the text editor, when we do undo and redo, the stacks are useful for that. So that was the one application of undo and for stack. The another application we can say recursion. So recursion is what? When a function is calling itself, then we call it recursion. So multiple, like a function is calling itself multiple times. So compiler uses a stack to maintain the previous state of the function, because it is calling itself. So it is changing the values or stats. So to maintain the previous states, it uses stack so that it can backtrace the function. In the similar way, balancing of symbol are the application of a stack. So if you use any programming language, or you use some code, so you use some brackets, like the opening and closing brackets you use for giving some some programming language. So compiler needs to check that the opening bracket, like closing bracket, should be same as opening bracket, so that it can be balanced. For example, the sine 2x is to power 2m plus 1 upon cos 10h x plus 3. This is the expression, and which came from that LaTeX code. So in this code, there are few curly braces and few small braces and open. So it needs to be confirmed like all are closed. The same, the number of opening brackets are similar as number of closing brackets. So how compiler do it? It stores all the opening brackets in a stack, and as well as the as soon as that opening the closing brackets come, it removes the open brackets from the stack. So if there are 5 open brackets and then closing bracket comes 5 times, then there will not be any bracket remain in the stack at the last. So it means opening and closing brackets are same. But if there some opening brackets remains there, or some extra closing brackets comes, then there is a mismatch of opening and closing brackets. So to balance the symbols, compiler uses the stack data structure. So yeah, is it clear, or any doubt, anything you want to say? Okay, so I will move to next slide. So that is a small introduction about tree. So we have talked about linear data structures. Now this is for non-linear data structure. So non-linear data structure is the data structure in which the data is not arranged linearly or sequentially. They are arranged like randomly. So for the different these data structure are used for a specific type of requirements, like it is a facility from the computer programs, like so that some specific type of data can be handled for like in a specific manner, so that it can be more efficient. So this is the tree data structure. So tree data structure represent the hierarchical data. So if you want to store some hierarchical data, then if you will use that tree structure, it will be, because it is a predefined data structure, it will be easy for you to store and traverse the data. So if you have an organization and in which you employees data is hierarchical, so we can say like the first is CEO. So it is, we can say Valis is CEO, and the reporting the person, the employee who report to directly to CEO is Dolan and Tucker. So we can create a hierarchy. Then the person who reports to Dolan are Davis, Logan, and these are the person. So this is the hierarchy of the organization. So in the tree structure, we can represent them. So the first initial node is called root, and the tree goes downwards. So from the root, these are the branches which are starting from the root, and then we go to other branches. These are called branch. Then the last nodes, after that no branches there, we call them a leaf node. So it is a downward tree. This is a tree structure. And in that, the data which is stored there in these nodes is like it is having a value, along with it has the address structure, memory address of its left node, as well as memory structure of its right node. So how the tree works in the computer program, every node, every data contains the value of that node, as well as the memory of left node, memory address of left node, and memory address of right node, so that it can traverse the left and right nodes with the help of that memory, because it is not sequentially arranged, and memory allocation is random. So it has to store the both of the memory address, so that it can traverse the different nodes. So that's how this tree type of data structure works. There are multiple operations we perform in it. These are predefined. So these are the details of that. I was telling about the introduction only. So this is a brief of a tree, which is a nonlinear data structure. So this is all the about the basics of data structure. I have just shown a basic idea about that data structures. So yeah, thanks for your attention. So if you have something you can discuss or any doubt. So is it clear? Anything, anyone wants to say anything?
Can you hear me?
Yes, I can hear you.
So, like when we are talking about a stack, we can compare, like you told this, like undo and redo whenever we do. If we want to connect it like tree, where can we connect in day-to-day life?
Day-to-day life means that computer, you are saying about that computer programs.
Yes, ma'am.
Yeah, so like the examples which I shown you, like that undo, redo, and in a computer program, generally compiler uses it for like balancing of symbol and many other things. If you have to check like the normal program, the compiler, if it used to a functions state, as I told you earlier, that recursion is also there, and for matching the symbols, for matching the, if you are having plus minus kind of like expressions, so you can put it in a stack and accordingly you can process. So there are many they like in the software, they are multiple examples of, like, by the daily life you mean, I didn't get your question exactly. Daily life mean?
Okay. I will just give an example. Like, if we are making a folder in our desktop, and we are making inside folder, we are making 2 folders, and then again we inside those 3 folders we are making another 2 folders. Is this a tree example, or I'm just making it up?
No, it is like there's like we don't need to store it in a hierarchical manner. Maybe you can use the tree structure, it's a structure for that, but it is not so complicated that you need the tree structure for that. It will be like normally stored easily. But yeah, if we can see it as a hierarchical data also. So it is your wish. I don't know how the computer store it internally, but yeah, hierarchical, like we can use tree also for that, but it is not much required because it is not so complicated hierarchy.
So in tree structure, we can insert or we can delete from any branch or at any step.
Yeah, but you have to traverse from the root node first. Directly you cannot go, because there are
So I will
multiple
have to
inbuilt
start
methods.
from the CEO.
Yes, you have to traverse. If you have to remove that, you have to go from there. Then only you will find the addresses of the different nodes, because you don't. How will the compiler know that address of like some between in between person? For example,
Look,
if we want to go
can we
to
show that
Davis,
slide? Huh?
yeah, if you go to Davis, so how will you go to Davis? You like if compiler don't know the address of Davis now, we only know the root node. Root node would have the address of Dolan and Tucker. So then we can traverse to Dolan. Like we will say that it is the left of that. Then it will have the addresses of these three nodes. Then so to go to some specific node, we have to traverse from the root. Then only we can go to the any of the node. Directly we cannot go, but that's why the loops and all comes into the picture.
No.